Welcome to the talk from Mario about cloud-native security. The stage is yours.
Hi everyone, or moin, wie man sagt. I'm here to talk about cloud-native security and why we need to talk to our security departments, and nobody wants to talk to our security departments because we all know all the security departments. Who am I? I'm Mario. I work for Kubermatic, and there I do customer projects and stuff for some development stuff. I'm also the communications tech lead for the Kubernetes project itself and part of the last week's in Kubernetes development newsletter. All right, let's go back. Let's go in the old world. In the old world, which started a long time ago and is still present when you talk to enterprise companies, we have the three main concepts of security. Our first thing is we have our parametric defense. That is our stone wall around our IT, and that is nobody can get inside. Then we also have reactive processes, so yeah, open a ticket with security. Or there's an issue, go and talk to security. And security does not talk itself to other departments, which is obviously bad because people should talk to each other. So when we go in our parametric security, I think the most prominent thing was there was one department of the US government, and they had walled off everything, firewall didn't get in, stuff like this. You can't get into the system because everything was shut off of the outside world. How do you get in? You drop a USB stick on the parking lot and someone picks up the USB stick and plugs the USB stick inside of your data center because people do stupid things. And this is what actually happened, and this is how they took over the system, and this is how they got all of the data. And we still have a lot of security departments in bigger companies that say, the outside world is evil, you cannot let in anything from the outside world. So this is the old world. But they don't keep in mind that hackers are no longer the people that are sitting somewhere in a dark room and doing like the things that we saw in Hackers, which is basically still the best hacker movie that we had in the past, and hack things with telephone booths and stuff like this. No, they do social engineering, which means they write emails, they try to get to your key card, they try to get into your system, they go through your system and basically dive into your security with your weakest point, which is layer 8, the human layer. Because every one of us is overworked, or it's too late in the evening, or for example, hey, let's do a meetup, and we have the meetup here, the pizza delivery guy coming into our office without any check and dropping pizza there. So basically, we have the human layer that we need to protect against. We have the parameter security that they build up. We have then the network security. And the deeper we get into each of the different details, the more critical our assets became in our system. And people start on the top layer if they want to get into your security. They don't start somewhere in the middle, because we know that somewhere in the middle doesn't help us in anything. The next thing that is bad is our manual and reactive process. So something happened, and then, oh no, something happened. We now have to react. And probably the reaction is somewhat bad. It's ad hoc. There's a chaotic way of doing it. And people are just headlessly running around. For example, we have 228,713 CVEs. This might have changed. This has changed because there are now 2 more new CVEs since I made the slide, which is 3 weeks ago. So there are vulnerabilities that we know of. That's also the point. CVEs is also the vulnerabilities that we know of. And the problem with the CVEs is not all of the CVEs are critical for you, because yes, you might have software that is affected by a CVE, but does the vulnerability really affect you? You don't know. Because when we look at it, this number is growing really, really fast. I mean, we had last year, we had over 5% more CVEs than the year before. And we have 24% more than 2021. And if we go a little bit back in history, you see how those CVEs exploded. And you also see that it really took a jump in the recent years, because more and more people are also now looking into things, and more problems are being looked after. But the problem is, you all need to keep up with this. You all need to fix things. And there was, for example, a CVE that was quite painful, because the CVE was affecting containerd, which basically meant that, oh yeah, we need to patch containerd. The problem was that if we want to patch containerd, we need to patch Kubernetes, and then we need to wait for our distributor that they patch Kubernetes, and then, for example, yeah, Flatcar didn't patch it. So we needed, if you run Flatcar OS, you needed to wait until the Flatcar patch came out to fix the CVE. So we also need to keep on top of this. And the last thing that is really, really a problem is it's a silo approach. Everything is, security is doing security stuff, development is doing development stuff, and ops is in between and says like, yeah, it's your problem now. We run it somewhere. So we have a lot of failed communication in between. Teams are not mixed. So people are in either this team or this team or this team. They don't know about technology from each other. They don't talk to each other. And it's always, yeah, the others are the bad guys. I don't want to talk to them because I don't like their nose. So basically, we have the silo approach. I mean, this got solved somehow when we said like, hey, let's use containers, because containers are cool, containers are nice, and we put everything into small microservices and put it then into, I can run containers anywhere. The problem is, this is not true, because it always is also reliant on the underlying system. And it solved one problem, that we basically got away from our lovely pets and kettle thing, where we said like, oh, this was my database server, and I gave it a name, and it was so cute, and in the cloud native world, it's some server, so we don't care about it. Another example, and this is the really, really bad thing, what is security teams always come, and this is basically to every security team that I talk to, is ports. Back in the days, port was a clear identification. So it said like port 25 is SMTP, port 22 is SSH. It was stateful. Every port definition was stateful. It was easy to manage because we know, as we said, SMTP is 25, so we know what's going on. And for the, it made risk analysis easier for people because, yeah, we knew what was running behind this. The problem is, in the cloud native world, ports are a thing. They are not necessarily bind to what is running there. For example, the worst security request that I ever got was, yeah, we want to use node ports in Kubernetes, but we cannot open 2,300 ports because the port range for Kubernetes is 30,000 to 30,200 something. And they say like, no, that's too much ports. It's a security risk. Nothing is behind it. What should go wrong? You can't open so many ports. So they limited it to 200 ports, and then they started 200 services, and then they were wondering why the 201st service didn't run anymore. Surprise. So in a cloud native world, we need to go away from the concept that a port means something. And also, I don't care if someone talks over the port. What is imperative to me is that I know who is talking to who in the environment, so that I can basically see who is the system that is talking to which system. And everything should be encrypted, because a port that is open or closed doesn't secure my application. Encryption is secure my application. And I shouldn't go away and trust anyone. So when we go into the cloud native approach, we need fine-grained access control, we need fine-grained identity management, we need to segment everything. So you go down and segment networks. So you say, like, I have a segment for my production, I have a segment for my site, I have a segment for any different part of the world. I use API gateways that I can declaratively say who gets access to what, and where is I have a central point where I can manage my access to the different things. That's also the reason why we have so many APIs that are interacting with each other, and Kubernetes is based on APIs, right? And the problem is not so much what is happening in my cluster, if it's okay. What I need to watch is something behaving not in the usual way in my cluster? So this is the thing that basically shows me what is happening. So yes, we still have ports, but they are not a security asset that we use. So I think this I don't need to explain because this is old. So we have DevOps was born. The original idea about DevOps was not that one person does dev and ops, because that's just stupid. The idea was, I have a team where I have devs and I have a team where I have ops, and they work together and they talk to each other. That's the idea of DevOps and not things. Also, we are now at the stage where in the past we said, like, services was pets and then became cattle, and then we had servers that became cattle, and so on and so on. And we are now moving into the world where clusters are becoming cattle. I don't care about my cluster anymore. I don't give a cluster a name, because a cluster is a fleeting thing. A cluster can die at any given point in time, and I need to be able to have my infrastructure built in a way that I can recreate the infrastructure out of the box in a declarative way again and again and again and again without any downside. So our key principles that we have for a cloud native world is we need to have everything automated, which means that every single part of our infrastructure need to be automatically reapplied everywhere at any given point in time. So we need to basically have a way that it's always rebuildable. And also the next thing is it should be immutable, because if it changes on the server side, this is a problem, because I can't recognize what developer X did in his console. That's not the way how infrastructure should work. So as soon as the code of the infrastructure hits the system, it should be in an immutable state. So no one gets access to an environment. That's the point. We have everything inside of our repository, and then you make a pull request, and then you can basically apply it or don't apply it. And we need to monitor every single bit of it at any given time that we have, so that we can see what is happening and what is not happening. And now, another phrase that probably annoys people, shift left. Everyone talks about shift left. The idea is still good. It's most of the times it's wrongly executed, because it feels like, yeah, you just hand over topics to the development, and we all know how good developers are with security. Hey, can you quickly open this port for me to run my unofficialized thing? So we basically need to go in a way that we start using different methods in the whole development process. So we need to have, in the early development process, we need to have static application testing. We need also then, if the application is running, so static application testing is white box testing, which means that we basically do security checks on code level, that we have checks on the code base, that in the code base everything is running and everything is secure, and we have dynamic application testing, which is basically black box testing, so that you constantly re-evaluate the running application and also like REST APIs, SOAP, and whatsoever to test it against it. So this is basically the first thing that needs also already to happen on development level, because if we don't do this on developer level, we already lost static application security testing. What we also need to do is, as everyone uses container because we put everything in container and then put everything in Kubernetes, there are problems in container libraries, like a ton, because people don't fix their stuff in container libraries. And you might rely on a level or on a registry that is not updating anything. So you need to make sure that your containers are that the container parts are also secure. The problem with there is maybe there is, or your container tool is checking like, hey, there's an issue with this image. The problem is, this image might not be a real problem for you because it's only in the build runtime and you don't care when the container is built. So this is always something that needs to be explained to especially security teams, that if your scanner says, hey, there's an insecure package, this might not affect you. That comes back to the CVE part that we talked about. It might not affect you, so it might not need to be, you might not be worried about it, so you can still use it. Also, we have compliance scans that are getting more and more interesting because we are in the European Union and we are the best with compliances and with laws and with creating stuff. So this is basically something that also can be automated in some kind of way. There it also needs to be taken care of, what does your company for compliances put in? So what compliances do your company put in? So the idea that we basically strive for is zero trust. I don't trust anyone. I don't trust my developers. I don't trust my environment. I don't trust my security team because my security team probably don't have the knowledge of the new world. So, and I don't trust anything that goes into my environment. So we start with basically no one can do anything, and then just slowly open up things. And we also put everything into small segments. So every time we define an infrastructure, we put everything into small boxes. And our new identity, our new parameter is basically the identity, because everyone needs to say like, hi, I'm Mario and I want to this service and I can go to this service because I have a green card. So there's basically, so we need single sign-on, we need authentication. I mean, we have with RBAC, we have one of the greatest fine granular tools in any given software that we can use inside of Kubernetes that we can just utilize. And it should basically be based on this. So Kubernetes and containers, when we go into those two topics, what we should, as security measurement, we should start, it's basically, we should go ahead and start container image scanning. So find vulnerable packages, find dependencies that are there, do it regularly, do it on a reoccurring base all of the time, prevent developers from using containers that are not allowed because people use stuff when they are able to. There are some tools that you can basically use. I reduced myself to open source tools because open source is great. And there you can basically go ahead and have like a vulnerability analysis, scanning for vulnerabilities, have integrations with your pipeline tools, for example, Harbor as your registry. So you can have it automatically inside of your registries. And this is a setup, and then update it because security vulnerabilities come up. So keep your systems updated. And that's also the reason why Kubernetes is releasing 3 times a year and not once. And that's also the reason why you should update stuff in Kubernetes, because old things are security vulnerabilities. So, as we said, that we need to also run constantly checks and behavior analysis in our cluster. There are a couple of tools that also can help you with this inside of your cluster. So we can basically go ahead and say, I want to have benchmarks of my cluster. I want to search for anything that is in my cluster, have vulnerabilities. There are some tools that basically do this for you. I'm sorry, I needed to put an AI tool there because I'm partly writing on this as well. The funny thing is, you can basically choose the backend, so it helps. It's fun and it helps. So if you want to check it out, KDS-GPT, it's the fastest growing CNCF project currently. Of course, we need to have a permanent observability. I mean, there are other talks around observability that go into more detail. So you should also focus on having this running inside of it. So we go basically to DevSecOps, which is the next step, and there it's we implement security. In the middle of it, we have analysis, we have builds, we have our dust and SAST, we have penetration tests on the development side. And yes, it takes more time, it costs more money, but you don't want to be the company that is leaking 4 million credit card data out of an S3 bucket, are you? So that's basically the next step of the evolution. And it all comes down to the most important thing: break up the teams and do collaboration. Do shared responsibilities, mix teams together. Have it as a process, not as a step. Have it always reapplied in your system. Have it always running inside of your system. Don't get fixed on a tool. I don't want to rely on a vendor that I pay for a security tool that is bought by another company and then costs twice as much. So you need to basically go ahead and plan it as part of your product or your environment. So we basically go ahead and have DevOps, DevSecOps, and platform engineering, and it's all belongs together. That's not an or different parts. It's one basically inherits the other, and it's a support for all of the different niches. And eventually we will have probably Triceratops that we will reach. I mean, we have DevSec, MLOps, but Triceratops is the better one. Thanks, everyone.
Thanks, Mario.
Any questions?
Are there any questions from the audience? I like the slide before that. Maybe you can put it on.
I can go back.
The slide. Are there any questions here in the audience? And for you taking pictures of the slides, they will be distributed afterwards, so you can have it as well.
All right, then enjoy the rest of the day.
Oh, there is a question on the other side. Yeah.
Yes, sorry.
Just give to... It's a long way to go.
Yeah, hi.
Hi.
Thank you for explaining us. Do you have any solutions for DAST? Because in general, for the open source, DAST is really tough. We have several prepaid tools, but open source, we have OZAP, ZAP, everyone uses. Apart from that, do you have any tools where we can tune more rather than just running the tool for the sake of DevSecOps? Because at the end, we need a secure product.
I mean, DAST is always the hardest thing to do because it involves the whole chain, and you mostly probably will need to either invest the time, as you said, or build a process by yourself. I mean, there from a platform point of view, where I'm coming from, to be honest, there are some things like black box exporter and stuff like this that you can run. But from a software development point of view, I'm the wrong person to ask. Sorry. Then, have a great afternoon. Bye, folks.